AOPS counting and probability 13.6. In how many ways can we distribute 16 chocolate donuts, 13 glazed donuts, and 15 jelly donuts among 4 people if each person insists on receiving at least 2 of each variety of donut? So we first distribute 2 of each to the 4 people so that they all get at least 2 of each kind of donut. So if we do that, there's 8 chocolate donuts left, 5 glazed donuts left, and 7 jelly ones left. So then the number of combinations for distributing the rest of the chocolate donuts is 8 plus 4 minus 1. Choose 4 minus 1 because there's 8 donuts and 4 people left. So that's 165 ways. And glazed donuts is 56 ways, same way, because there's 5 glazed ones left. So 5 plus 4 minus 1, choose 4 minus 1, 56. And jelly, since there's jelly left, it's 7 plus 4 minus 1, choose 4 minus 1, which is 120. So in total, there's 165 times 56 times 120, which is 1,108,800 ways to distribute all these donuts. AOPS counting and probability 13.8. Which of the identities below are valid? For the valid identities, prove the relationship using any method you like. For the invalid ones, provide a counterexample, meaning find values for the proposed identity for which the proposed identity doesn't work. So A is this. So if this one doesn't work, because if r is equal to 0 and n is equal to 3, then the actual sum of this side is equal to 0, choose 0, plus 1, choose 2, plus 2, choose 4, plus 3, choose 6, which is 1 plus 0 plus 0, which is 1. And over here, n plus 1, choose 2n minus 2r is supposed to be equal to 0, but 1 is not equal to 0, so this is not a valid identity. And B is this. So all terms on the left is in the form k times k minus 1 times k minus 2, because so for example, if this is k, 2 is k minus 1, 1 is k minus 2. If this is 5 is k, 4 is k minus 1, and 3 is k minus 2. And then, so k choose 3 is equal to k times k minus 1 times k minus 2 over 2 times 3. And 6 times k choose 3 is equal to k times k minus 1 times k minus 2. And over here, this is 6 times k choose 3. And C is this. And this is invalid because if n is equal to 1, then the left side becomes 1 plus 1, which is 2. And the right side is supposed to be equal to 1, choose 1, which is 1. But 2 is not equal to that, so it's invalid. AOPS counting and probability 13.10. In how many ways can we distribute 7 pieces of taffy and 8 pieces of licorice to 5 kids, such that each kid receives exactly 3 pieces of candy? So first we need to distribute 7 pieces of taffy to 5 kids such that no kid gets more than 3. Then we give each kid enough licorice so that they have 3 pieces of candy, because they have exactly 3 pieces. So the number of ways to distribute 7 pieces of taffy to 5 kids is 7 plus 5 minus 1, choose 5 minus 1, which is equal to 11, choose 4, which is equal to 330. So only one kid in this can receive more than 3 pieces, and there are 5 choices to who that kid is, because if that kid has 3 pieces, then the rest each have 1. So there are 5 choices to who that kid is. So 3 plus 5 minus 1, choose 5 minus 1 is 7, choose 4, which is 35 ways. So we allocate 4 pieces to that kid and the 3 to rest. So there's 330 minus 5 times 35, which is 155 ways to distribute the taffies, since they can't have more than 3 pieces. So then there's only one way to give enough licorice to each kid so that they have 3 pieces of candy. So there's 155 ways.